Today we are going to continue our discussion on board layout in Eagle and introduce some more advanced board layout concepts. Here is the schematic of the board we will be working with today. The board will take a 12-volt input and produce two different voltage outputs, 5-volt and 3.3-volt. The board uses two different voltage regulators to accomplish this. If you want to learn more about them or find the circuits we use, you can look up the part numbers for their datasheets. Now that you have a general understanding of board design in Eagle, we can discuss more complex board design techniques. Let's start by talking about multi-layer boards. Multi-layer boards are PCBs that have more than one layer that you can route traces and solder components to. This allows us to do much more complex signal routing and introduce concepts like ground planes. Eagle defaults to a two-layer configuration, so no additional setup is needed for designing two-layer boards. You can view the top and bottom layers by changing the visibility settings in the layer setting menu. Now that we have two layers to work with, we can route signals between the layers to avoid traces that you would normally not be able to go around. Traces on different layers can be connected with vias. A via is a hole drilled into the PCB and filled with conductive plating to connect signals on different layers. While routing, you can place vias by hitting the spacebar on your keyboard or clicking middle click on your mouse. Notice that this will switch you to the opposite layer automatically. You can also place vias by clicking the via button on the side ribbon and dropping it on an existing trace. Another important tool for multi-layer boards is the polygon tool. When using polygons, the unused copper on the inside of the polygon is not etched away and is instead used as part of the circuit. For a two-layer board, we typically specify the bottom layer as the ground plane. Using a ground plane is important because it makes sure all the components connected to it have the same ground voltage, minimizing interference and ground loops from other parts of the circuit. Ground pins on a device should each be directly connected to the ground plane. To draw a ground plane, you can use the polygon tool to trace the outside border of the bottom layer. Once you've connected the polygon edges, using the name tool, you can enter the signal name as GND ground to specify the shape as connected to ground. Once you have done this, run rat's nest to fill the shape in. Once you have specified a ground layer, you can route traces, place vias, and place components on the layer. Eagle will isolate the signals from the ground layer so that they do not touch. However, you want to be careful not to route too many traces or place a lot of components on the ground layer. You want to avoid a condition called islands. An island is formed when traces on a layer cut off a section of the ground plane from the actual circuit's ground connection. In this case, the island is not actually connected to ground, and any ground traces connected to the island will not have a connection to the ground. If sections of the ground plane are too thin, we start running into the issue we had before of sharing return paths and ground loops. So it is best to minimize the amount of signals routed through the ground plane and ensure that the minimum width of any part of the ground plane is enough to handle the circuit's current. If you have too many signals on the ground plane, it may be useful to look at board designs with 4 or more layers. You can also use the polygon tool for power supply planes and large current signals. This can make power distribution easy on yourself, and if the power plane is bigger than your regular trace width, it will also help with heat dissipation. Just like the ground plane, you can draw out the border of the signal and then label the shape with the trace name. Once you fill your plane, you will notice that all of the pins connected to the plane have a cross around them. This is a thermal, and it helps contain heat flow on the pin, making it easier to solder. However, this type of connection dissipates more energy during high current flows and is physically weaker than a fully connected pin. For this application, we want to prevent Eagle from connecting components with thermal isolation. To do this, use the Info tool, uncheck the thermals box, and click OK. Now when you run rat's nest, the connected pads are covered by all sides of the polygon. Multiple vias can also be placed under high power devices in order to channel heat to the other side of the board and keep the device cooler. These types of vias are called thermal vias. Often you will want to mount your PCB to some other structure using screws or standoffs. This is where mounting holes come in. Using the hole tool, you can place holes and specify the hole diameter. Make sure not to have any traces routed near the vicinity of mounting holes. Screws can eventually wear through the solder mask, and you do not want screws shorting your signals. Shorting traces to the mounting chassis not only runs the risk of damaging components on the board, but can present a shock hazard. Thank you for watching our second video on Eagle board layouts. Check out the links in the description for more information and stay tuned for our next video on making PCBs.